Okay, this little video is about Aqua Ions questions. In this video, I'm going to be using this knowledge. Q, out, 3 plus, 3 plus, 2 plus, 2 plus. We're going to be reacting with OH minus, excess OH minus, NH3, excess NH3, CO3 2 minus. Now what you'll need to do these questions is you'll need a grid like this, either drawn out or just known very well inside in your head. But I'm going to be referring to this diagram throughout. I'm going to tell you a couple of other things that you'll need to be able to answer this question, because you need to be able to answer a lot of. You need to have a lot of other knowledge. God, I couldn't get my words out there. So I know that everything in this column is the same as everything in this column. I know that aluminium 3 plus reacts with excess OH minus. I know what goes in this box. I know what goes with this box. This box is ligand exchange. If you look at the previous two videos, you'll know what I'm talking about. I know that these two things are special. They just do the metal carbonate. I know all of the colours of these because this is the same as this, this is the same as this, this is the same as this, is the same as this, this is the same as this, is the same as this. I know that carbon dioxide and water are produced as well. Shall we crack on? Right, the other bit of information that's not mentioned in any of my videos is to do with copper, and it's the fact that, CuCl4 2 minus is another copper complex that you need to know about, and you need to know the colour. This is a tetrahedral complex with the large chloride ligands, and it is a yellow, and it's negatively charged, so it's a yellow solution. This also lives on here. Other information we'll be doing from today on these questions, you'll need to know a little bit about ligand exchange in general. So with things like the EDTA 4 minus ion, maybe a little bit of what we call the chelate effect, which you should have done prior to this. I do have a video on that from a few years ago. So let's see if I've got enough information here to be able to answer these questions. Remembering that aqueous ions, Fe, H2O 6 times 3 plus, and all of these, they are all weak acids. And we know why that is. All right, so I'm just going to go and get a pen. I'm going to pause the video temporarily, get a pen. Oh no, you can hear me go and get it. I'm not going to pause it just in case I break it. I'm just going to get a pen. Walking around the lab, trying to find a pen. I've found a pen, it's in my hand. Right, so these are the questions that we've got for this. I might lower the camera a bit, it's going to get shaky. Earthquake, slick production values here. Look at that. Wow. Okay, so question number 1. The figure below shows some reactions of iron ions in aqueous solution. FeH2O6 to FeH2O6 2 plus to 3 plus. This is something else I hadn't mentioned. Goodness me. This precipitate here can turn into this precipitate here in the presence of oxygen. It oxidizes. So there's a couple of cool arrows you can add onto your diagram. Oxygen turns this green precipitate into this brown precipitate. It turns the green into the brown precipitate. So yeah, I forgot about that. Here we go. Right, so what we've got here is iron 2 plus, iron 3 plus, adding carbonate in air. Okay, identify A and state its colour. So this is iron 2 plus with carbonate. I know that that is FeCO3. Because look, iron 2 plus with carbonate makes the metal carbonate. Colour, everything iron 2 plus is green. Give the formula of B and state its colour. So iron 3 plus with carbonate makes the only thing that you make with iron 3 plus, which is FeH2O3, OH3, and it's a brown precipitate. There we go. Because with iron 3 plus, this is the same as this is the same as this. And that is FeOH3, H2O3. The ionic equation for the reaction of this with aqueous NaCO3. So when they say ionic equation, we don't need to include the sodiums. So I'm going to start off with FeH2O 6 times 3 plus. I'm going to add some carbonates, SCO3 2 minus, and I know it forms FeH2O3 OH3. I know it also forms CO2 because it fizzes, and I know it forms H2O. I've balanced this equation before on the previous video, so I did it by saying let's make these charges balanced. 2 of them, 3 of them, 2 of them, 3 of them, 3 of them, and I've just rattled out 3 marks really easily. I haven't got a mark scheme here, I just know my way around this diagram. Right. Explain why an aqueous solution containing iron 3 plus ions has a lower pH than one containing 2 plus ions. Lower pH means more acidic. So basically we've got a metal 3 plus pulling electron density towards itself from the ligand. So the metal ion pulls electron density towards itself, which weakens the OH bond in water, so H plus ions are lost into solution. So I would write that, I would say the metal ion pulls electron density towards itself. It weakens the OH bond in the H2O ligand. Sorry about the rushed writing because I've just got to go and pick up my kids from school. It weakens the OH bond in the H2O ligand, so H plus is released into solution. Now that does not answer the question yet. That just says why they are acidic. But why does the 3 plus make it more acidic than the 2 plus? Well, the 3 plus ion is more charge dense. They will also accept it's got a higher positive charge and it's the same size. So it's more charge dense than the 2 plus. So it weakens the OH bonds more. So more H plus is released. There's lots of ways of arranging that, but basically 3 plus are more charge dense than 2 plus, so more H plus are released. Okay, let's have a look at this. They like these sort of flow diagrams. So I'm in the world of aluminium. So I know my aluminium row is basically aluminium can make Al H2O 3 times OH 3 times. That's here, here, and here. And the only other thing it makes is Al, as far as we're concerned, OH6 3 minus. There's some other things you can write in this box, but that's the one we're going to learn. Okay, so, right, they're adding it to some EDTA. Well, that's interesting. So I know that if you add it to EDTA, EDTA just replaces everything. You'll make aluminium EDTA. EDTA is 4 minus, that's 3 plus. So overall that will be 1 minus. It's going to be colourless because that's not a transition metal. Aluminium with carbonate will make aluminium H2O3 OH3. It'll fizz, it'll make some water. Aluminium with hydroxide. Well, if you look at aluminium with hydroxide, it'll make that precipitate first and then it'll go on to make this. So it'll make Al H2O3 brackets OH3 first, and then it'll go on to make Al OH6 3 minus. White precipitate, colourless. Right, give the formula of the white precipitate B. I've done that already. Al H2O3 OH3. Observation, when carbonate is added to this, you'll get a white precipitate. Equation. I've just done this one for the iron. Al H2O6 3 plus carbonates. They don't want the sodium carbonate bit, they just want the carbonate. It's always accepted. Okay, 2 of them, 3 of them. You'll make 2 Al H2O3 OH3 plus 3 carbon dioxide plus 3 H2O. Done. Give the formula of the complex ion C. Complex ion C, aluminium OH6 3 minus. Oops. That's the special box for aluminium here. The condition, you need excess NaOH for its formation, and the equation for its formation will be, and its formation for the formation of C from this. Okay, they want it from this. So I'm going to write aluminium H2O 6 times 3 plus. I've not written this equation before. And I'm going to end up at AlOH6 3 minus. I'm going to add, to do that, I'm going to need 6 OH minuses, and I'm going to make 6 H2Os. Cool. Remember this thing, if it's got a charge, it's a solution. If it hasn't got a charge, it's a precipitate. If it's got a charge, it's a solution. If it hasn't got a charge, it's precipitate. The charge can be positive or negative, it'll dissolve. Deduce the formula of the complex ion A. Alright, well I've done that already. Aluminium, EDTA minus. EDTA forms 6 coordinate bonds to central metal ions. It's got a 4 minus charge, the aluminium is 3 plus, that's where I got that from. I haven't actually looked at the mark scheme yet. I hope I'm not making a hash of this. I don't think I am. I think I'm getting it all right. But, you know, that could be misplaced confidence. Let's just check the mark scheme. Yeah. Yeah. Yeah, I'm getting it all right. Cool. Go me. Is that the next one? Explain with the use of an equation why a solution containing that has a pH of less than 7. So it's asking why it's acidic. Well, I remember that. Remember this idea. Just wrote this before. Central metal ion pulls electron density towards itself. Tick. This weakens the bond in the OH. This weakens the OH bond in the water. Tick. H plus ions are released into solution. Okay, that bit's fine. The equation to show it being acidic is this. H2O6 3 plus. And what we do is we just say that all we're going to do here is show that 5 of the waters stay the same and one of them, so this goes down to 2 plus and it releases an H plus into solution. There's a little problem with that. It should be a reversible arrow. So what this equation shows is one of the hydrogens of the water ligands dropping off, that OH there was an H2O, and releasing an H plus into solution. Alright, so that is why why metal aqua ions are acidic. This sort of equation is one that you have to be able to draw to show acidity, and that's the explanation. Alright, I love these diagrams because they remind me of my grid that I use. Right, so I've got iron 3 plus. Now I know a lot about iron 3 plus. Iron 3 plus forms these brown precipitates with pretty much everything. So what are they doing here? Iron 3 plus with carbonate. So I know that'll make the brown precipitate. They're probably going to ask me for this equation. I'm going to have to balance that with carbon dioxide and waters, but I've already done a couple of that example today. That's precipitate J. Reaction 3 seems to be turning iron 3 plus aqueous into iron 2 plus aqueous, so that is getting reduced. So you need some sort of reducing agent. Okay, don't know what that'll be. Hydrogen? I don't know, see what it says, reducing agent. Tin, there's an organic one in there, tin and HCl, I don't know. And then you've got iron 2 plus with ammonia, and I know iron 2 plus with ammonia makes iron 2 hydroxide, FeH2O4OH2. Let's just check that on my diagram, just so you know that I'm not making this up. Where have I put my diagram? Alright, FeH2O3 plus carbonate. Fe3 plus carbonate makes the precipitate. I haven't got any of the fully drawn ones that I've got last time, but you should know this from previous videos. Then it says iron 2 plus with ammonia takes it to this green precipitate. What's going on here then? Reaction 2, HCl. Right, HCl is basically Cl minus ligands, so you're basically just going to get FeCl4 minus. You only get 4 chloride ligands, you end up with this. Makes a tetrahedral shape. Because chloride ligands, chloride ions are really big and you can only fit 4 of them around a central metal ion. That's from a previous topic, so that's to do with ligand exchange. So when you see conc HCl, it's basically just adding Cl minus. Alright, give the formula of precipitate J. I've done that, FeH2O3 OH3. Give the colour, iron 3 plus brown. Everything's brown apart from this is orange. That's an orange solution, that's a brown precipitate. Equation, I've done that one before on previous questions. Turn over, give the formula of L and an equation for reaction 2. Alright, formula of L, it must be this, FeCl4. You can only ever get 4 chlorides around these things. The equation, let's just make it up. So it started off like that, and I know it ended up like this. So you just got to get used to blagging it. 4 chlorides, so that's going to be 4 Cl minuses. Kicks out 6 waters. Kicks out 6 waters. Should be a 1 minus on this side, 1 minus overall on this side. Looks good to me. Suggest a reagent for reaction 3. This is the one I knew I was going to get to. A reducing agent. What should I go for? I might get this wrong. I don't know a reducing agent particularly. Well, I know that's a reducing agent, NaBH4, from organic chemistry. I also know you can use tin and HCl. I'm going to go with NaBH4. I might have just dropped the mark. All that misplaced confidence. What did I get? Did I get it right? No, I should have gone with the... right, zinc in acid. Or CHI. Don't know what that means. You know what? I'm not going to get that done in the video. I'm going to... agents, reducing agents. Iron 3 plus to iron 2 plus. I do think that NaBH4 should do it. I'm going to back myself on that, but I'll do some research into that. So, sorry, you're not getting a definitive answer to that one today. Give the formula of precipitate M. Precipitate M, I've done that. It's the iron 2 hydroxide. State its colour, iron 2, green. They're all green. Iron 2 plus, right? Green solution, green precipitate, green. You don't need to do forest green, sage green, or anything like that. Just green, 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 green. All right, aluminium, right? This is a tricky little question here because it's trying to catch you out. It says, when anhydrous aluminium chloride reacts with water, solution Y is formed. The chloride's a distraction. When aluminium reacts with water, you make aqueous aluminium ions. So write a solution, so there's aluminium chloride, AlCl3. You're expected to know that at A level. It's group 3. It reacts with water, H2O. It's going to form aluminium H2O 6 times 3 plus. And to do that, it must kick out 3 Cl minuses. It tells you, you make chloride ions. There you go. So we've made aqueous aluminium. Give an equation to show how complex Z can act as a Bronsted-Lowry acid. Oh, we've just done this one. It acts as an acid, so there's Al H2O 6 times 3 plus. It acts as an acid by getting rid of an H plus, and it gets rid of the H plus by H2O 5OH. There. We did that equation on the previous question. Describe 2 observations you would make when an excess of sodium carbonate is added to Y. Oh, let me remind myself what Y is. Right, this is solution Y. In excess of sodium carbonate, 2 observations. Observation 1, a white precipitate. It doesn't ask me for this, it asks me in the equation in a minute. But that white precipitate, by the way, I'm just going to preempt it, H2O3, OH3, that one, yeah? The aluminium's white precipitate. And the second one, it's going to fizz because it gives off carbon dioxide. It didn't ask you for these, it's asked you for the equation. The equation, we've done it a couple of times already. Aluminium H2O 6 times 3 plus CO3 2 minus makes Al H2O3 OH3 plus CO2 plus H2O. 2 of them, 3 of them, 3 of them, 3 of them, 2 of them, done. Is there another question? Okay. Aqueous potassium hydroxide is added to solution Y until excess. I mean, they're just rinsing out the aluminium column. They've asked you a question about this. They're now asking you a question about this interesting section here. That makes sense. Easy peas. If you know this, you can see why they're asking you. They're going to ask you about this part, they're going to ask you about this part, they're going to ask you about these, they're going to ask you about the tricky to balance equations. They're probably not going to ask you too much about copper. Alright, describe 2 observations you would make. Potassium hydroxide in excess. Alright, observation 1. Firstly, you get a white precipitate. Look, white precipitate forms here. We're then going to say in a minute the white precipitate dissolves and gives a colourless solution. White precipitate forms from a colourless, my writing is abysmal when I write fast, solution, but whatever. Equation 1, so that's aluminium, H2O 6 3+. Let's do the white precipitate, so you get 3 OH minuses. It's going to make aluminium H2O 3 OH3, and it's going to make 3 H2O. Observation 2, the white precipitate dissolves, forming a colourless solution. Equation 2 then, so I'm going to take that white precipitate, Al H2O3 OH3, and I'm going to turn it into this colourless solution. Don't know why I'm saying that, getting excited because I'm nearly finished. 3 OH minuses, 3 H2O. Mic drop. Phew. Good luck in your chemistry exams. If you're actually in my class watching this, I'm going to be checking this. I'm going to be checking that you've marked it too, please. Yeah, learn this stuff really, really well, then you don't have to revise it. Rather than revise, just try vising it first time round. Bye.